welcome to the channel. The motto of the channel is to facilitate students in learning physics at their convenience. It is a class without a classroom. So learn physics at your convenience. Let us start our today's lesson, that is Coulomb's law. Students, we know that the charges interact with each other. Means the similar charges repel each other and opposite charges attract each other. How much the charges attract or repel, or the force of interaction between the charges depends upon what factors. This was explained by Coulomb in a law known as Coulomb's law. This law states that the force of interaction between two charged bodies is directly proportional to the product of magnitude of the charges and inversely proportional to square of the distance between their centers. It means the force of interaction, whether it is attraction or repulsion between two charged bodies, depends upon number one, the product of magnitudes of the charges on the bodies. More the charge on the body, more will be the force of interaction. Less the charges, less will be the force. Secondly, this force of interaction depends upon the distance between the charges, and it is inversely proportional to square of the distance. It means that making the distance double reduces the force 4 times, and making the distance half increases the force 4 times. So force is inversely related with the distance. Farther the charges, less will be the force. Closer the charges, more will be the force. To further understand the Coulomb's law, let us consider two bodies with charges q1 and q2 are separated by distance r between their centers. Now students, according to Coulomb's law, the force of interaction between them is directly proportional to the product of magnitude of the charges. Mathematically, F is proportional to q1 multiplied by q2. If we increase q1, force increases. If we increase q2, force increases. And similarly, by increasing both the charges, force increases. Secondly, this force is inversely related with square of the distance between their centers. This relation shows that increase in the distance decreases the force, and decrease in the distance increases the force. We combine these two facts in the form of single equation like this. F is proportional to q1, q2 over r square. q1, q2 are the charges, r is the distance, F is the force. Now, when sign of proportionality is replaced with sign of equality, we multiply right hand side with some constant. Here, k is the constant of proportionality. Students, it is the mathematical form of Coulomb's law, where q1, q2 are charges, r is the distance, and k is constant. Value of k depends upon the medium between two charged bodies. In case of air, value of k in SI units is 9 into 10 to the power 9 Newton meters square per Coulomb square. And since this value of k depends upon the medium between the two charged bodies, therefore, in terms of medium, we can also write value of k like this: k equal to 1 over 4 pi epsilon naught, where epsilon naught is called permittivity of free space. Students, it is the mathematical form and statement of Coulomb's law that explains the nature and value of electric force between two charged bodies. I hope it is clear. Students, thank you for sparing your time to watch the video. If you liked it, don't forget to subscribe the channel. Take care of you. Goodbye.